Hello and welcome to another exciting episode of Breakfast with Unity. This one's really exciting because we're going to be doing something that a lot of people always ask about and very few people answer. How to do actual, honest, true, pixel-perfect rendering in Unity. So let's get started. So first off, I'm going to create a new scene. Actually, we're already in a new scene. This is, in Breakfast with Unity, we are defaulted to the editor mode being 3D. So I'm just going to make some quick adjustments to this level to make it ready for 2D. So our camera right now is rendering the skybox. We don't want that. We're just going to render it to a solid color. And we're going to set it to an orthographic projection. So this is now a 2D projection. And so that's all we need to do basically to make this 2D. We can also click this little 2D button so that we get a 2D view of what we're working with. So we're going to need some content on here to see what's going on. So first let's look at how we import the assets and make them work in here. I'm going to be using Kinney's wonderful platformer art pixel redux, or redo. This one's actually a reduced version of his sprites. I'm going to show you a sample here in the Sprite Sheet. So you can see that these are little like smaller pixel versions than his previous packs that he's done. Now, the trick with this pack, and I wanted something more optimal than this, but bear with me, is these individual tiles are not powers of 2. It's not a problem, but from an optimization standpoint, you will get better results with powers of 2, especially in this case because we're going to have to use a render target that is going to be directly based on ratios of our pixels. And if it's not power of 2, you'll basically have a little bit of extra overhead on the graphics. It's not a big deal. We're going to work with it as it is. It's probably not going to affect any projects on PC, and it probably wouldn't even affect your projects on mobile, but it might. It does cause a little bit more rendering cost. So we've got the Sprite Sheet, which has all this stuff on here. And through a little bit of trial and error, also, I made one modification to the Sprite Sheet from the pack that you can get from Kinney, which the information is in the license. The difference that I did is his just had a blue background here. I've changed this to a transparent background. It looks gray here, but it's actually transparent. That's the only modification I did ahead of the show. And I apologize I didn't show that on the show, but it's not really... I just did select color in Pixelmator and deleted that color. So what we're going to do is we're going to change the texture type to Sprite. And after looking through this stuff and measuring things out, I found that the Sprite Sheet is actually 21 pixels per character. And it's multiple characters. So we're going to go to the Sprite Editor. We could have Unity auto trim this, but it's going to do bad things because some of these pieces are designed to have set centers, and this is already set up as a grid. So we're going to use grid, and the settings for this particular one are 21 by 21. That's the size of each of these little blocks. They are offset on the page by 2 and 2, and they are padded by 2 and 2. So if we slice this, it'll take just a moment. Unity will slice each of these into individual sprites, and you'll see, I'll show you the... once it's sliced, I'll zoom in on this and show you exactly what was done with these settings. Once we have this done, I'm going to just grab a couple of these tiles and we're going to show the pixel problems in Unity. And actually, this is a problem in other engines too, but like this is, I want to show you how to work around it in Unity here. So we're going to zoom in, and so this is how everything was sliced. You can see that we've got these 2 pixel gutters. The offset was based on the page offset, so there's a gutter around the whole page, and then each of these is a 21 by 21 sprite, and they're ready to go. So we're all cut up. There's a couple that are really small little overhangs and stuff. We're just going to be grabbing a couple of big block things to show what's going on. So let's close that, hit apply. So, and we're using pixel per unit 21 because each of these blocks is 21, so that makes it nice for working with the physics system and stuff. So I'm going to grab one of these sprites, preferably one that's a nice little block here, and drag it into the scene. So, first off, let's just see what we've got here. Now, we're going to make the camera size, let's make it 2. So, we're using bilinear filtering right now. I didn't change that. We're still on filter mode bilinear. And in bilinear filtering, you don't run into the problems with pixel perfection, but everything's blurry. This is one of the fixes for pixel perfect. It is one of the worst ways you can fix the problem, in my opinion, because it makes things blurry. If you want nice looking sprite art and you want the resolution to be lower than the screen resolution virtually, like you want the pixels to be bigger than 1 pixel on a screen, because pixels are real small these days, you're going to want bilinear filtering off and just use point filtering. So let's change it to point filtering. So point, apply. Right now, as I said, we're going through what the problem is. So hopefully you'll be able to see this. This is a little bit tricky. We are broadcasting, right? Yeah, okay, good. This is a little bit tricky. If we move this thing around, you'll see that, like, look at the corners especially. These are your telltale signs. When we move, you'll see that they sometimes increase or decrease in size. And the reason this is happening is because in point filtered, you're going to have very sharp edges. And so you're going to be able to notice little differences like the number of pixels per pixel. The problem here is we have screen pixels, which are on my screen here. And then we have our virtually smaller pixels here. And sometimes there's like 5 pixels per pixel, and sometimes there's 6, and sometimes there's 4. And it depends on where you are on the screen and how far offset this is. And so you get this like resizing little problem. And so I've brought in a file that really shows this off really well. All this is it looks really strange when you're zoomed out. View, we need it to be actual size. So what this is, no. Why? It just zoomed to fit when I chose actual size. What is... No, you're a horrible editor. What? Zoom... Okay, well, I'm just going to zoom in so you can see what it is. All this is alternating pixels, black and white. It looks like gray sometimes because of video encoding and also because of the way screens display things, but what it actually is just alternating black and white pixels. So what's nice about this is this will immediately show the size offset for each pixel. So I'm going to just drag it into the scene. Bam. That looks terrible. It should look like a bunch of discrete pixels. You should be able to see a black and then a white, and they should be the same size everywhere. They're not. It is very, very not good. So yeah, so this is no good. This is no bueno. So we can resize it. Oh wow, evidently at this resolution it just happens to be. No, it's still not right. Okay, so it's just closer, but if you see here, there's actually a couple lines. God, this hurts my eyes to look at. This line's shorter than the other lines. Sometimes, depending on your screen size, you'll get different effects. Like you can have some that if you have it really close to the right ratio, you'll see that it starts to look better. And if it's really far off, it'll look really far off. I'm actually glad it's really far off right now because it allows us to see the problems easily so that you guys can understand what's going on here. So yeah, so that looks awful. I'm just going to go ahead and delete this again. Okay, so actually, before we delete this, so there is... Some people may have been using Unity for a while, and they may have noticed something that looks really promising. So I'm going to create a new material, and we're going to need this material eventually, but we're going to call this pixel offset. And we're going to change the shader to Sprite's default. And there's this little... Actually, I'm going to call it pixel snap to match what it's called. Pixel snap. So pixel snap, this looks really promising. You click this, and it changes the material so that this now actually will offset the material so that everything is pixel aligned. However, this only pixel aligns to the screen or the current render buffer. So if you're pixel aligned to the screen, this does not solve our problem. So if we go to our dots here and we change it to pixel snap instead of Sprite's default, you'll see that it did change things, but it's still not right. All this did is made it so to make sure that every object, that this object now is aligned, even if it's offset a little bit, it will be perfectly aligned to the pixels on your screen. If you're doing a high-resolution sprite game, like if you're doing a sprite game that's intended to be viewed on a high-resolution device, and each pixel is designed to be a pixel on the screen, all you need to do is set that pixel snap stuff. Just set that on every sprite you have in the game, and you're done. But if you are making a traditional sprite game that has a lower resolution, and you want to be resolution independent of your platform, that's not enough. As we can see right here, it did not solve our problem. So, we got to go a little bit further. So, I'm going to show you my setup for making this awesome. I'm going to first revert this from Pixel Snap because I want to go back to it later. We're just going to put this back to Sprite's default. And I'm just going to leave this in this. Actually, I'm going to delete this from the scene for right now. I'm just going to keep this little sprite here. So we're going to create a new camera. And the reason I haven't done this before on the show is because the technique I'm going to show you required Unity Pro before. It does not require Unity Pro anymore as of 5.0. So I'm going to put this camera at Y1000. This is just so that we don't have to worry about like masking it or anything. So this is way up in space. We're not going to see it. We don't care about it. We have this camera. I'm going to create an empty child inside the camera, and we're going to call this the Pixel Resize. And then we're going to create one more child, though it's going to be a quad. We're going to create a quad and put it into Pixel Resize. And this quad, right now it just has a white texture. So what we're going to do now is we're going to create a render texture. This is a texture that we can render to. We showed this on our render texture episode. I think that's what we called it. And we're going to call this virtual screen. So now, this is going to be rendered to by our camera. Now, resolution is important here. What are we doing at the camera right now? So we've set the camera size to 2. What this means is, it means that there will be actually 2 units from the center of the screen to the top of the screen. So 2 game units will be represented in that. So what this means is the total screen size is actually 4 units, and we have 21 pixels per unit. So that means our resolution is 21 times 4, which is 84. So, as I said, if you use power of 2s, you'll get nice power of 2s answers here. So, like, if you use 32, it'll come out to, like, 128 or something if you just keep all the ratios nice and even. We're not doing that, so bear with it. So, here we go. We're going to go to the virtual screen. So, what I like to do is, most screens are wide these days, so I usually do a double resolution in the width. So we're going to do 21 times 4 for our vertical resolution, so 84. And then we're going to do 84 times 2 for horizontal resolution, 168. And we're going to choose main camera, and we're going to render to this virtual screen. And we're going to go to our quad, and we're going to set this at a 2:1 ratio. And we're going to make another material, create material. And what is this called? This is called virtual screen material. And on this one, we're going to set it to unlit texture. This is one of the simplest shaders in all of Unity. And we're going to drag our virtual screen onto it. And then finally, we're going to drag this onto our quad. So now our quad shows what our camera is rendering. So if this is our only camera in the scene, so we're going to change the settings on this to be 2D, so we're going to make it clear to solid color. Actually, we could probably get away with don't clear because we're going to... Let's do solid color. Actually, this is actually a good example because I'm going to make the solid color black. So solid color, orthographic, and so we've got this quad, this 2x1, which means that we want the camera to render 0.5 tall. So this will exactly cover our render area here. Now, the width of it right now is based on the camera width here, which is true. So we'll have basically borders. So if we go to the game view right now, sorry, not the 2D, game view. Okay, we're not done yet because the quad's not in the right position. We need to put the quad forward a little bit. Actually, I'm going to put we'll put the quad forward by 5. There we go. Okay, one more thing. We already got the bilinear thing again. That's because our virtual screen also needs to be set to point. There we go. So now we've got a camera. We've got our pixel resize thing. I named it that for a reason. You'll see it in a bit. And we've got our quad. And we're rendering to a texture. So this is actually a camera. All this rendering to the screen right now is this camera that's pointed at a texture that's being based on another camera that's rendering this to a texture. I know that sounds complicated, but yeah, all you have to do is make sure that your gameplay is in front of the main camera and make sure that nothing is in front of this camera other than this quad. That's all it's there to render. So what else do we need? So at this point, we still have the same problems that we had before. If we move our sprite, you'll see that it has some pixel crawl to it. If we put our dots on the screen, you'll see that it has the dots problem. Where did this end up? Good, 0, 0, perfect. So we haven't solved it yet. Now I've got this script here. I'm going to go over it. We're not writing this on the show because I wanted to make sure that it was absolutely right. It has a couple of optimizations. The main optimization is it doesn't do the recalculation on the screen unless the screen resolution changes. So it does it once at the start of the program, and then any time that you resize your window, it redoes this calculation. And what this does is it's got two modes. It's got prefer uncropped and not cropped. And so I'm going to show you the difference between those right now. So we're going to put this on our pixel resize. And we're going to set the vertical screen pixels to, what was it, 84? And I'm going to go ahead and bring in our, actually, we'll bring in that after that. I'm just going to move it around here. So if we hit play right now, you will now see that we now have borders on the screen. The screen has been cropped. But if we move the sprite around, okay, there's still a little bit. It's very, very rare, but you get a little bit of that problem. So the way we fix that is we go to pixel snap here. Because as I said earlier, if you turn on pixel snapping, it snaps to the screen resolution or your render target's resolution. So now this is actually properly snapping to pixels at the size of our target virtual resolution. So now if we go in here and move this around, you'll not see any resizing if everything's going right, which I'm pretty sure it is. The other way we can prove this is if we put our wonderful dots thing in here. Looks horrible. We hit play. There. That's... Oh, wait. Still off by 1. Sorry. We still need to do the pixel snap on this one as well. Actually, let's do that while it's running so that you can see the difference. So if we hit play... So it's still a little bit off, and it's off because the corner's off. If we do pixel snap, it so didn't fix it. Why does that look off to me? Maybe I did my math wrong. Hold on. Let's make sure we've got everything set the way we want it. I'm going to put pixel snap on it ahead of time just in case. Hold on. Play. Yeah, it looks off. Here, I'm gonna make this bigger. No, is it? Maybe it's not off. No, that's right. Certainly a lot better than it was before. So it seems like it's just a little bit wrong at the top and bottom here. I think this is a problem you wouldn't have if you were doing Power of 2 stuff. I may redo this with Power of 2 textures just to double check, but you'll see that it's considerably improved. What this is actually doing is resizing this this quad, basically, by resizing the parent, based on the vertical screen pixels. And so what we end up here is we end up with something that unfortunately it's not perfect right now, which is annoying me. But as I said, most of my testing was done with the Power of 2 stuff, and I didn't find it. Open Game Art is down today, believe it or not, so I actually grabbed stuff from Kinney, and I was hoping it was Power of 2, but it was not. I'm making excuses now. That sounds horrible. But yeah, this is at least way closer. Now, the other option here in Pixel Resize is we've got Prefer Uncropped. If you change this to unchecked, what will happen is you won't have the screen edge problem, but you will crop the scene slightly. The reason that we see black on the sides here is because our aspect ratio is ridiculous. If you have anything that's a normal resolution, you're not going to see those. The reason is because we're doing double horizontal resolution. So let's go back here. Was there something I did wrong on like the import settings for dots? This point? No, it's true color. Okay, so there's not a problem there. But yeah, with these settings, let's go ahead and switch it to not the dots. And let's go ahead and make this really big. we can now move, well, let's not make it really big, I guess. Let's just make it, whatever. I want to be able to edit things. So, where is it? Pixel Resize, Sprite Sheet. So if we move this thing now, you'll see that it will only move in nice, static pixel chunks. And the other problem that sometimes you run into with other solutions is you can have half pixels. This does not have that. So if we put another sprite in here, the pixels will always align. So where's my sprites? We're going to go to Platformer Art, Sprite Sheet. I want a little character. There's a little character. I'm going to bring him in. And we're going to give him Pixel Snap. And now when we move him, you'll see that he always fits the same boundaries as the other objects. So I'm going to put them near the bottom of the screen just so you can see the clipping. If we change this and then we change it to pixel resize and we do not prefer uncropped, you'll see that the bottom of this has been cut off. The amount of cutoff and the amount of borders is based on how close to the resolution that you can get. The point is to make this exactly square pixels, so each pixel has to be the same number of pixels as other pixels. And in order for that to actually happen, we need to change the size of things such that what am I doing? Such that there's always the same amount of pixels available, actual screen pixels per virtual pixel. And so that means that we basically have to either choke it up to the next highest resolution or down to the next lowest resolution, which is the difference between having this checkmark on and this checkmark off. So if this checkmark is off and you do this, you'll basically get the same effect that you get in the brilliant Sonic CD remake on any platform. If you play that, all the pixels are always exactly the right size, and it always goes to the edges of your screen. So if you have a wide screen, if you're playing 4:3, you'll see less screen. If you're playing 16:9, you'll see more screen. If you have different resolutions, you might see a little bit less or more at the bottom or top. So yeah, hopefully that will cover people. It will always look bad in Editor just because I don't have this running in Editor. We could probably make it run in Editor and it would be fine, but let's do that. Let's just do it. Execute in edit mode. Save. All right, and let's see if it starts executing. There it is. So now if we're in edit mode, it will do the resize automatically, and so you can see it even in edit mode, things are working. So what's left? That's just not, I'm annoyed by that. So I'm going to try something real quick. I just want to, since, as I said, we were doing this with a sprite sheet that has weird sizes. I just want to make sure that this does look right if we have a power of 2. So I'm going to switch our dots here. We're going to change the the screen resolution to 128 by 64. And we're going to change the camera so that that's appropriate. So, the camera here. So, wait, 0.5. Why is that such a point? Oh, yeah, that's right. So the main camera we're going to set to render. Oh, yeah, sorry. So dots has to be changed in the import settings to be, let's make it 32. Apply. And that really looks different than I thought it would. And then finally, the main camera size 2, that means 2 times 32, sorry, 4 times 32 is 128, so that's right. Oh yeah, and this needs to be set to 128. There we go. So if we hit play now. Okay, so evidently, let's try 16 pixels per unit. 16, apply. There we go. So yeah, that looks right. And if we change this, yeah, that still looks right. So yeah, if it's not, so if you're not using Power of 2, it's not going to be exactly perfect. It's going to be very close though. Most users will not see the difference. Unlike the other previous stages that we saw during development where it does not look right. I'm going to switch this back to what we had before though. So 84 pixel snap. We want this to be 21. Apply. We want this to be. Oh, whoops, we're in play mode. I don't want it to be in play mode. So 84, and we want virtual screen to be 84 by, and I can't multiply in my head for some reason, 84 times 2, 168. One of the things that I didn't do is this doesn't real-time update, so you'll have to hit play for it to actually update if you need to change that. Typically during development, you're not going to need to change that very much. You can modify that if you want. I'm going to leave that to you. So I'm going to go ahead and get rid of the dots here, and we're going to put the... Where's the character? I thought we had a character, didn't we? Did I just delete him for some reason? Let's bring him back. There we go. Let's bring him in here. Give him the proper... So again, without pixel snap, he can be offset in ways that are not natural for pixels. He can be offset in strange ways. So we'll just go ahead and pixel snap him. There we go. And now everything's hunky-dory again. So I'm going to go ahead and save scene. Pixel snap. I wanted this episode to go a little bit smoother than it did, but yeah, there's a lot here. So anyway, let's go ahead and save it, and yeah. So thank you very much for joining us. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfire, that's DRAKFYRE. If you have any questions, or yeah, I already said that. Yeah, thank you very much for your time, and you guys have a great one.